Hello, friends. I'm back with the chemistry videos. So, today we will learn about carbon, carbon containing compounds. Carbon containing compounds. Okay. First of all, let me give you one basic information about carbon. Its atomic number. Atomic number of carbon is 6. What is the mass number? Mass number of carbon is 12. It means it has 6 protons, 6 electrons, and 6 neutrons. Okay, friends. According to electronic configuration of carbon, if we want to see the electronic configuration, which will be according to atomic number, its electronic configuration would be 2 and 4. There are 4 electrons present in outermost shell. Outermost shell. Let me take the example of S, P, D, and F. So shell, 2 electrons come here, and in this 8 electrons can come, rest of 4 can come here, and the outermost shell it contains 4 electrons. Okay, so this carbon is tetravalent. What is it? It is tetravalent. Okay, let me discuss more about carbon. Why we use carbon only and we do not use other elements such as nitrogen, oxygen, sulfur. There are so many elements are present, but why we use carbon? Why we study in organic chemistry about carbon only? Uh, then we should discuss about its uses first of all, where we use carbon. First of all, in all living organisms, we use carbon. We have carbon present in all living organisms. All living organism. Okay. Second use is in fuels. We see all fuels, there are carbon present in it. So carbon is an important part. Fuel is made up of carbon. Third one is all organic substance or organic substance, such as carbohydrate. Okay, carbohydrate. We can say it can be protein. Okay, alcohol. All are made up of carbon. Okay, these are the main uses of carbon in living organisms, in fuels, in organic substance like carbohydrate. Okay, let me discuss about the uniqueness of carbon. Why we discuss only about carbon? What is the uniqueness of carbon? Uniqueness means it is unique in all the elements. Why it is so unique? Why we study in organic chemistry? Why we are discussing more about carbon in deep? So what is the uniqueness of carbon? Let me discuss about that. So first of all, we talk about the uniqueness of carbon. What is the uniqueness? Uniqueness of carbon. Okay. Uniqueness. Uniqueness of carbon. First of all, there are more carbon elements, more carbon compounds than non-carbon compounds. More carbon containing compounds are there. Containing compounds are there as compared to non-carbon compounds. Non-carbon compounds are less, but carbon compounds are more. Clear? Second one, carbon compounds form huge number of compounds. Carbon is element form huge number of compounds. It form huge number of compounds. So it is unique. Okay. Now let us discuss about the properties of carbon. What are the different properties which made carbon special? Okay, there are four properties of carbon and which make it special. And first of all, we will discuss briefly about every properties. Okay, so the first property of carbon, I will write down here about properties. First one is catenation. 1 minute. Okay. So I can write here catenation. Very important property of carbon and very uh, common property. Second one is you can say tetra covalency. Tetra covalency is the another property of carbon. Third one is polymerization. Okay. And fourth one is isomerization. These are four properties which make carbon unique. The very important properties: catenation, tetra covalency, polymerization, and isomerization. Let me discuss in brief about every property. So, first of all, I will discuss about tetra covalency. Tetra covalency, as I earlier said, that carbon has tetravalency. It has four valency. That's why it is known as tetravalent compound. It is known as tetravalent compound. So I will write down here about tetravalency. Okay, tetra covalency. Let me discuss about covalent compounds. What are covalent compounds? Covalent compounds are formed by sharing of electrons. Sharing of electrons. Okay, so carbon only form covalent compounds by sharing of electrons. Now the question here arises that why carbon only form covalent compounds? Why doesn't form ionic compounds? What will be the answer then? As I said that its answer lies in its carbon structure. Its valency is 4. It has 4 electrons in outermost shell. So let me write down the question. It's very important question. Why carbon only form covalent compounds? Covalent compounds, not ionic compounds. Not ionic compounds. So you can take the screenshot of this question because it's very important question. So let me take the screenshot for 2 minutes and I will rub that. Okay. Let me discuss the answer of this, that why carbon only form covalent compounds. We know that covalent compounds are formed by the sharing of electrons. Both the elements will share and make their octet complete. Okay, so it is made by sharing of electrons. So we know that carbon valency is 4, 2 and it's 4. Okay, either it can 4 electron, it can lose or it can gain 4 electrons. Okay, carbon. In the case of lose, it needs more energy, Carbon doesn't have so much of energy, so it cannot lose 4 electrons. In the case of gain, we know that 6 electrons are already present. Okay, and 6 protons are already present. So if we add 4 electrons here also, 4 electrons, I write here also, then it will be total 10 electrons. Okay, 10 electrons would be there. So it makes the nucleus unstable. So it will neither lose or nor gain. Only it share the electrons, and that's why it formed the covalent bond. Carbon only forms covalent bond. Neither it can lose, neither it can gain, because I have given the reasons for both of them. Neither it can lose or neither it can gain, nor it can gain. So it can only form covalent compounds with the sharing of electrons. Sharing of electrons only do, and it completes its octet. Okay, now let me discuss about the next property that is known as catenation. Catenation, very good property and very common property of carbon. See, catenation which leads to direct bonding between atoms of same element. Bonding between atoms of same element. There should be bonding. There should be bonding between atoms of same element, either in straight chain, either in branched chain, or in cyclic form, That property is known as catenation. Let me give you an example of this. If we made a straight chain of carbon, then how it would be? It made branch chain, how it would be, and it will made cyclic structure, how it would be. So it bonded with the atoms of same element. That property is known as catenation. Let's take an example. C H we know the carbon valency is 4. We will fulfill the valency of carbon. Now it is straight chain. This is a straight chain. So the elements are all carbon. We cannot take the other element like oxygen. So the bonding between carbon and carbon atoms in straight chain, or if here we can say that the branch will be present and it will be branch chain. So it is the property of catenation. Okay. So this property is very common and very useful for carbon. Let me discuss with you another property of carbon, that is polymerization. That is polymerization. Polymerization. Polymerization, what do you mean by polymerization? If monomers, if monomers combine to form polymers, that process is known as polymerization. Now the question arises, what is monomer? Monomer is monomer, we can say they are compounds of two carbon atoms is known as monomer. For example, I can take that C double bond C fulfill the valency. Okay, this is one monomer. This is one monomer, and the chain of this monomer will form polymers, and the process will is known as polymerization. What will be its name? It two carbons are present, and the double bond is present. That is known as ethene. The structure is known as ethene. Now, let me take one more example of it. How the monomers attach and make the polymers, and the process is known as polymerization. So let me take one more example. Okay, C single bond C H H H H. Okay, and I'll write down, and here this is the number of chains. This is one monomer. Okay, it will multiply and it will make polymers. So this property is known as polymerization. Okay, so the next property, if we talk about, that is known as isomerization. Very good property and very important property of carbon. That is known as isomerization. Now let's see the definition of isomerization. What are isomers first of all? Isomerization. Isomerization. Same molecular formula, but different structure formula, but different structural formula. That is known as isomerization. Let me take one example of butane. Butane. There are four carbons will be there. Okay. This is butane. Formula is C4H10. We can write like this also. 1, 2, 3, and 4. And this formula will also be what formula? C4H10. But the structures are different. The structures will be different. The formula of this will also be C4H10, but the uh, molecular formula is C4H10 only, but the structure is different. So it is an isomer. Okay, this property is known as isomer. So these are four properties that I have discussed with you. So another part we will discuss in the next lecture, the second part, the IUPAC nomenclature, and such that how can we give the nomenclature. The the rest of the things we will discuss in the next part. And I hope you like my video. And you can subscribe my video and you can learn many things. So thank you. Have a nice day. Bye.